Hey, it's Mrs. Wagner here. To my Algebra 2 students, we're doing week 5, which is one of the weeks from 511 to 524. So, hey guys, I created this pencil today because I was bored and had an eraser on both ends, and then I realized it was pointless. It was pointless. All right, so moving along here. We're going to look at indirect measurement today. So, indirect measurement is where we measure things where we don't have to actually get out and figure things out. We can go ahead and measure it by using angles and different things. So, Carl Sagan has this really cool video, which I really want you to see this video, where he shows how Eratosthenes calculated the circumference of the Earth. It's really cool because he calculated the circumference really close to what the real circumference is just by using trigonometry. So here is an article that I took, which also says the same story, but again, the video is really what you want to look at. If you look at the video, you're going to be able to answer these questions. Some of these answers are right here, but most of the answers to this are on the video. I just think it's a really cool story, and I want you to look at it. So, getting back to indirect measurement, I realized as I was going through this and making a video that I have some things that were incorrect. So, for instance, this 4 feet 10 inches, that is 4 feet 10 inches, or 4 and 10 over 12. 10 over 12 because there's 12 inches in a foot. So 10 over 12 turns out to be 0.83. So 4 and 10 over 12 is 4.8.3. So that's what needs to go here in this fraction and not the 10 that I had on the page. So you need to make that correction. So when I do cross multiplying is multiplying what's across. It would be 5.5 times x, which is what you have here, and then the other thing that you would have is 4.8, which is again the new thing that I changed, times 125. So once I do that, I am going to get 5.5x, so that should have an x there, equals 600, and then dividing by 5.5, you get about 109.1. All right, so that's indirect measurement. So Andy is looking at the Eiffel Tower. He measures a point 500 meters from the base of the tower. He places a small mirror there, and then he stands behind the mirror so that when he looks in the mirror, he can see his reflection. Okay, so that's a certain type of reflection. We didn't really have time to study it a lot. But if we were in school, we would be studying that type of measurement, and we actually had mirrors and everything we could use, which would be cool. But we're just going to suppose that we're going to do it. Okay, so x is to 500 as 1.8 is to 2.75. So I want to set up that proportion. Again, I want to cross multiply x times 2.75. Which gives me this right here, and then I want to do 500 times 1.8, and then I want to figure out what x is. So I'm going to let you finish that. So you want to multiply these two numbers, and then whatever number you get, I want you to divide by 2.75. All right, so let's play around here by solving some of these proportions. So I need to get my paper out. There we go. So what proportions would I be setting up here for this? Well, I'm actually going to grab this, okay, and yes, my students do rock, they really do. So here we go. I think this will be darker, so I'm going to use this one. So I'm going to say the tree is x. It doesn't work. All right, I got other choices. Hopefully this one will be better. So I have x is to 2.5 as 1.9 is to 1.5. So there we go. Okay, so x is to 2.5 as 1.9 is to 1.5. So coming back over, we can see how I would do that. So all you have to do once you get that proportion is solve for x. So how do you solve for x? Well, you cross multiply. So you'd multiply these two and get 1.5x equals 2.5 times 1.9. So 2.5 times 1.9, you get a number, and then you divide by 1.5. That's how you would do that problem. Looking at the next problem, we have 5 is to 8. So I'm going to write 5 is to 8 as x is to 24. So I'm writing that down, and then I'll come back up here, and you can see it. 5 is to 8 as x is to 24. And then I expect you to solve that for x. Number 3, what type of proportion would you do for that? You would do x is to 30 as 5 is to 4. All right, so I expect you to try to write a fraction for that. X over 30 equals 5 over 4, and use cross multiplying for that. For number 4, x over 90 equals 54 over 36. All right, so those should be pretty easy. I like to start out with things easy, and then I like to turn it up a little bit of a notch. So moving on to angles of elevation and depression. So an angle through which the eye moves up from the horizon to look at something is an angle of elevation. So I just want to show you. There we go. Hey guys. So if there's a leak on my ceiling and I'm looking straight ahead, I cannot see the leak on my ceiling. So let me look this way. I cannot see the leak on my ceiling. I have to look up to see the leak on my ceiling. So that's why it's called an angle of elevation. So if I look straight across, I cannot see the leak on my ceiling. I have to look up. And that angle of looking up is an angle of elevation. If I'm looking straight ahead and I dropped my pen, I can't see my pen if I look straight ahead. I have to look down to see my pen. So from here down is the angle of depression. So if we were in class, it would be a lot easier, but we're not. I put some pictures so you could see. The lady looks up to see the balloon, but the person on the balloon has to look down to see the lady or gentleman. I don't know. I can't tell whether it's a lady or a gentleman. Okay, so I kind of explained that. So I want you to practice a little bit and see what you think. If John looks down from his second floor window to see a cat, what do you think that is? That's depression, right? If Sally looks up to see a squirrel in a tree, oh, that's elevation. If a pilot looks down to see the runway, that's depression. If a captain on a ship looks down to see a submarine, that's also depression. But if a girl looks up to see her friend on a mountain, that's elevation. So hopefully that was somewhat easy for you. I'm hoping, because I'm just trying to take little baby steps here to get you to where you need to be. Okay, so from a point on the ground, from the foot of a tree, the angle of elevation is 35 degrees. So here's my 35-degree angle right here. I put a little arc on it, and then I did my DT going across, and I did my OPP for my opposite side. From a point on the ground 47 feet from the foot of the tree, so I'm going to use here. Here is my point on the ground right here, and here is the foot on the tree. So this is the distance right there, 47. So 47 would be right there. So what trig function would I use to figure out how tall the tree is? Well, I say opposite. I don't have anything on the hypotenuse, but I have adjacent. So if I have opposite and adjacent, it's tan. So whenever you take tan, it's always of an angle. So tan of 35 is x over 47. So I just multiply by 47, and I get x is equal to 32.9. Going down to the next example. So we have a hot air balloon. There's a 90-foot rope. So the rope is right here. Here's a person hanging on to the balloon right here. Right here's the person. They're holding on to the rope that goes up to the balloon. So that's why the 90 is there. Or actually, there's a stake in the ground. Sorry. From the balloon, the angle of depression is 62. So again, if this person was looking straight across, they couldn't see the stake in the ground. They have to look down at 62. Well, one thing that you have to keep in mind, though, is if this is 62, this is also 62. They're actually called alternating interior angles. If this is 62, then this is 62. But that's geometry. Some of you will learn that next year, maybe. Okay, so I explained that right there in step 2. Solve the problem using trig. Well, what do they want to know? They want to know the height of the balloon. Well, where's the height of the balloon? Right here. Right here's the height of the balloon. Right here. Okay, I've drawn that kind of bad, but here's the height of the balloon. So I'm looking for this. Oh, it's probably going to do something with that. Yep. So I'm looking for this, right? So I could say that's my x right there. Do I have adjacent? No, I have hypotenuse. So opposite hypotenuse, that's sine. So the sine is going to be x over 90. And in this case, all I have to do is multiply by 90, and I get 79.5.